All right, so standard tenure, solving log equations. Actually, numbers 1 through 4 on this are not solving log equations. This is not standard 10. These are all standard 7. How would we solve each one of these? The same base, yeah, we would get the same base. Yeah, so if I was doing like number 3 here, what would be the same base for number 3? 2. So 8 is 2 to the third power, and then 1/2 is 2 to the -1. Yep. Oops. What would I do with these exponents right there? Yeah, multiply. Oh, that's weird. There. Okay, yeah, so we had multiplied these powers, so we get 2 to the 3 minus 6x equals 2 to the -1, and then what would I do? Yeah, we would set the exponents equal. Yeah, so we go from here to there, and then we just solve for x from there. So -3 minus 3, we have -6x equals -4, we get x equals 2/3. Okay. So that's standard 7. Get the same base, set the exponents equal, etc., etc. Let's go down to the bottom of the page. Let's go to number 9. Okay, can we get the same base with 3 and 15? No, we cannot. We cannot. Not with exponents, at least, which is the key. Okay? But what it's saying here is that x is the power that turns what into what? 3 into 15, right? Can anyone think of a different way to write that? X is the power that turns 3 into 15.
So I think it would be log 3, and then you put a 15 in the, I don't know, we call it unit.
What do we think? Does this communicate the same thing? That x is the power that turns 3 into 15? Yes. That's the answer. Yeah. So this log represents the power that turns 3 into 15. Now, it is a weird decimal. It's a number that's between like 2 and 3. But the most exact way to write it is log base 3 to 15. So this process right here is a process called exponentiating, which means rewriting it as an exponent. So number 10, and this one's just one step because x is sorted by itself already. We're going to exponentiate. What would that look like? X equals log base 5 of 50. Yep. And that's the answer. That is fully simplified. Now, there's there's ways that we could take this question further. We could ask you to expand log base 5 of 50 as much as possible. The problem's not asking us to do that, but it could. So that could be like, okay, this is log 5 of 25 times 2. this would turn into addition, right? Nice.
I like how there's two questions.
Yeah, that's what I thought was question. So I can split this up into log 25 plus log 2. What does this number equal right there? Yeah, that equals 2. Log base 5 of 25 is 2. So if the question asks us to expand, we can do that. The question did not ask us to do that. So we don't need to, but just to show you that it's possible. Yep. Oops. Okay. On the next page, down here, because I know you have a little room, I'm gonna add another question here. You can put it just like right there in that white space there. Okay, so if we exponentiate this, what could that look like? There's actually a few ways. What would x equal? X is the power that does what? Turn your neighbor, talk about it. Okay, how can we say this? X is the power that turns what into what? Four into 5 to the x plus 1, right? So x is the power that turns 4 into 5 to the x plus 1. Yeah, it is weird.
It's like middle.
Okay, here's another way to think about that. So you might find this easier. What we can do is we can take the log of both sides. So we're allowed to do the same thing to both sides, right? And we can pick base 4 or base 5. Let's pick base 4, just because. So if I pick log base 4 of both sides, so just take both sides and put them inside of log base 4. What does the left side equal? What power turns 4 into 4 to the x? X, right? 4 going to 4 to the x, what would I add? I would add an x. Okay. So the left side equals x. And so we get this. So notice we get the same thing. Just saying, it's another way to think of it. Take the log of both sides. Okay, from here what we want to do is we want to take this exponent and move it down. This exponent has to go all together, so when we bring it down, it's going to be in parentheses. Okay, and now to solve for x, we need to do a little bit of advanced algebra 1. So that advanced algebra 1 is going to look something like this. So give this one a try here. I want you guys to try and solve for x. Get x by itself. It's kind of difficult, but give it a try. See if you remember how to do it. No, that's okay. We'll just go over it. Okay. First step, does anyone know what it would be?
Divide by y.
Okay, so if we divide by y, this is what we get. Don't divide by y. That's not the right answer. But if I divide by y, this is what I get. So now we actually had an x by itself, but now it's with a y. And now this one's by itself. I don't know. So here's the problem with this. I still don't have x by itself. I now have one x by itself, but now the other one's not. Right? So our goal is to try and get one x by itself. All right, so we don't want to divide by y. Good idea, but wrong. That happens sometimes. Okay? Other thoughts? Divide by x plus 1. Okay. Good idea. Is x by itself? Yeah. No. Distribute the y. Yes, that is what we want to do. Yeah, now we still don't have x by itself. All right? Okay. So now we have x equals xy plus y. Divide the whole thing by x. If we divided the whole thing by x, no, that's not the answer. Yeah, it would look like this. And now, yeah. Yeah. I mean, that actually could get you to the answer, but in a more roundabout way. Other ideas? All right, here's what we're going to do. We're going to subtract xy from both sides. So we distributed. And then the reason that we do this is to get all the x's on one side. So get x's on one side. We are very, very close to getting x by itself. Ideas. As I look on the left side here, I notice that these two terms have a GCF. What is it? X. I can factor out a GCF.
Oh.
Oh.
One, two, divide by 1 minus 1.
Divide by 1 minus y. And now x is by itself. Nice. Oh. Where did it go? Where did that freaking, did I delete the page? Maybe I did. Yeah, I think I did. Okay. So. Nice. Now, this is Algebra 1. Is it the Algebra 1 that you spent the most time doing during Algebra 1? Absolutely not. Right? Normally you're solving for x a lot, you're getting x by itself, but very rarely with two variables, we're just trying to get one. Okay, but that's really all we're doing, just kind of manipulating an equation to get x by itself. I'm going to give you guys a very similar one. Fine. Just in general, from the beginning. I just made up an equation that's similar to the one that we're solving. Yeah. We'll do one more that's kind of like this, and then I'll make the connection to the logs. Yeah. It's a good clarifying question. Yeah, so I'm just adding one little plus 2 in this. Same here. Solve for x. The process is going to be really similar. There's just going to be an extra step in there. So a big hint with this is if you follow these step-by-step instructions here, that's how you solve it. All right, let's go over this. So what's the first step? Distribute. Okay. What's the next step? Yeah, and what's my goal here? Give access to one side. Okay, so subtract xy from both sides. So I have x minus xy plus 2 equals y. Now, can I factor out x right now? No, because it's not a GCF. I need to make it so that the GCF is x on the left side. Yeah, we need to get rid of the 2 as well. So it's really get x's to one side, get everything else to the other side. Now, can we factor out the x? Yes. And then last step. Divide. Okay. Now, sometimes I'll see answers that look like this. I'll see 2 minus y over y minus 1. Are those the same? They are the same. Those are the same answer. Those are the same answer because it just depends on what side you put x on. So like back here on this step, or actually no, not back there. On this step right here, if instead of subtracting xy, you subtract x from both sides, you put it over there, and you put the y on the other side, you can have like the turned around version of this equation. So the reason these are equivalent is they're just like the negatives. It's like the top is negative and the bottom is negative. So sometimes I'll see answers that look like that, and that's fine. Okay, so here's the connection. This first equation that we did, this one right here, is identical to what we're about to do with this log equation in number 13. Okay? Instead of y, we have log base 4 of 5, which is a more complicated looking thing, right? It's a bunch of letters and numbers. It's kind of weird, right? But we're going to follow the same process. So what was our first step? Distribute, yeah. Boom, boom, we distribute. So just imagine that's the y right there. Once we distribute, what do we do?
Factor out the
First, the x is on one side. So that means we need to subtract x log 4 of 5 from both sides. Oops. Okay, and then yeah, back up GCF. And then divide. So x is like this thing right here. I'll write it up here so it's a little bit cleaner.
Working on a task and replace like 1, 4, and 5 is replaced with their number.
Absolutely, absolutely. So if you guys didn't hear the question, Vivian's question was, is it okay if I like substitute in y for log base 4 or 5 or some other letter and just do the algebra like this so that it's less writing and then substitute it back in at the end? Yes, absolutely. Absolutely. Writing one letter is way less time than writing 3 letters and 2 numbers, right? So you could solve this equation like this, substitute y back in at the end. That's totally fine. Okay. Yeah. Just to differentiate between the two kind of stages of this problem, the material that we're talking about, this is the pre-calculus, the log stuff where we're using properties of logs. This is Algebra 1, the rest of it. It's not easy Algebra 1. Just because it's Algebra 1 doesn't mean it's easy, right? There's tons of Algebra 1 stuff that you would still find very difficult. But in terms of just why are we doing what we're doing down here, it's all about just isolate the variable, right? Solve for x. You learned that in Algebra 1. The pre-calc part is about getting it so that you can do Algebra 1. Okay, let's take a look at the problem on the top here, number 11. Very similar problem to the one we just did, except now both exponents are a little more complicated. That's okay. We're going to start by taking the log of both sides. We have a number of choices of what base to choose. We can choose 5 or 6, or actually we can choose any other number, but 5 or 6 make the most sense. What are you guys going to do, 5 or 6? 5? Okay. So take log base 5 of both sides. So we're going to have log base 5 of 6 to the x plus 3 equals log base 5 of 5 to the 2x plus 1.
So is that log 5 on both?
Yep.
Explain how you got there.
We took the log base 5 of both sides.
Oh, okay, so
Yep.
you just want them to be equal.
Yes. I just have to do the same thing to both sides, right? So it's like 5. Add 5 to both sides, multiply both sides by 5, take log base 5 of both sides. Yeah, I'm allowed to do that. Yeah, go for it. Okay, on the left side of the equation here, where the bases don't match, what do? Same thing as from the last problem, so you can look down at that one. Yes, we're going to move the exponents in front. So on the side where the bases don't match, we move the exponents. On the side where the bases do match, the non-super math way to say it is basically the log base 5 and the 5 cancel out, and we're just left with 2x plus 1. The more mathy way to say that would be that what exponent turns 5 into 2x plus 1? 2x plus 1. Okay. Once we do this, the pre-calculus part is finished. We've done all the pre-calculus that we're going to do in this problem. The rest of it is algebra 1, and it's going to be very, very much like this equation here that we did second, because the left side's a little bit more complicated. But we're still going to follow these steps. Distribute, get the x's on one side, factor out the x. That's still our process here. Oops. So, what was first again? Distribute. So distributing this log base 5 of 6. Next step. Okay. So I'm going to subtract 2x from both sides and move it over to the left. So x log 5 of 6 minus 2x. Do I want to do anything else in this step? I want to subtract this 3 log 5 of 6. So I want x's on one side, everything else on the other side. Yeah, this is not good real life advice. You really don't want all your x's in one place, but in math, it's good. Now what do we do? Factor out the x. Get x to one side, factor out the x. Oops. All right, and then we're almost done. What's the last step? Divide. Yeah, this is my final answer. It's kind of gross looking. I mean, it's, I don't know, there's just a lot going on there. I'll just leave it like that. Which part would you say is the most confusing part of this problem? The pre-calc part or the algebra 1 part? The pre-calc part? The algebra 1 part? Who thinks the pre-calc part is the most confusing? Who thinks the algebra 1 part is the most confusing? Yeah, that's typically what it is, right? The algebra 1 part. It's just weird because we're not used to working with so many letters and numbers all at once. It's kind of crazy. Okay? But the good news is that you're understanding the pre-calc for the most part. Not 100% of people. Some people still think pre-calc's hard, which is fine because it's a weird concept. But pre-calc's there. It's just the skill of the moving and manipulating the equation, the basics. Not that the basics are easy to get, but so that just means the best way to get better would be practice. Cool. Why don't you guys practice number 12?
So I don't have space.
You can work on a separate sheet of paper. That's fine. So before we start number 12, just so that our answers look the same, do you guys want to do log base 3 or log base 7? 3? It doesn't matter, but let's just pick one so that we all have the same answer. 3? All right, we're doing 3. So there, I told you guys the first time. I'll take like 30 seconds here and then we'll check. All right, you guys, let's check. So again, for the algebra part, these are going to be our steps. So we're going to follow those. To solve for x, we're going to distribute, get the x's on one side, which also means get the other numbers to the other side. Factor out x. And we're going to finish by dividing. So, oh boy, look at that. It's kind of crazy looking. Okay, so we're taking the log base 3 of both sides. So log 3 of 3 to the x plus 2, log 3 of 7 to the 2x minus 1. On the left side, what do we get? Left side we get x plus 2. Yeah, so that one, the 3's cancel out. On the right side, what do we do? Yeah, move the exponents down. Okay, pre-calc done. So now we're doing algebra 1. First step of our algebra 1 process. Distributes. Oops. Second step of our algebra 1 process.
Or one to one side.
Yeah. X's to the same side here. This 2, right? We need to subtract that. Yeah. So get x's to one side. I literally almost wrote an ex. X's to one side. Then factor out the x. And then divide. Cool. Really ran out of space here, huh? Okay, the most common thing I was seeing out there was right here at this step, when you factor out x, that is going to give you a 1 minus right there. Because we got to think too, the best way to think about it is if I redistributed x, would it take me back to the step before? That 1 there allows me to get that x. Okay, now we got to do the other examples. These are a little bit easier, but we got to go to that page before there. Number 5 on the notes page.
Oh, you want us to do that?
I'm going to show you it. Okay. So for numbers 5 and 7, we're going to use the same sort of problem-solving strategy. Number 6 is going to be a little bit different. Number 8 is also going to be different. So basically just giving you some different looks here. Okay, in number 5, we want to exponentiate this one, which means rewrite as an exponent, yeah. So when we rewrite this one as an exponent, which one of these numbers is the actual exponent? The 3, yes. The 3 is the power that turns what into what? 2 into 7x minus 6, right? Yeah. All right. From here, kind of similarly, that's the pre-calc part. Now we're just doing algebra 1. Is this algebra 1 a little bit easier? Hopefully, yes, right? What's 2 cubed? 8. Then we add 6. Oh, yeah. Feeling good. Then divide by 7. There we go. That's nice, huh? That is nice. Cool. So exponentiate. I really want to exponentiate when there's a number on one side and x is inside the log. That's kind of my indicator to exponentiate. So for number 7 here, I am thinking I need to exponentiate this one, but first I need to condense. So I'm thinking exponentiate because there's just a 1 on one side, and there's logs on the other side. So condensing using properties of exponents, if these 2 logs are added together, what's going to be inside my 1 log here? Addition turns into multiplication. Okay, so we condensed. Check. Exponentiate. What would this look like? Yes. So 1 is the power that turns 6 into x plus 3, x plus 4. Check. Okay, we're back in algebra 1. Here we go. What would I do to solve for x? Huh? Distribute, yes. Distribute, FOIL, multiply, etc. FOILing is really just double distributing if you think about it. I wish that's how they would teach it. Okay, now we subtract 6. Yeah, we got to get this set equal to 0. Now, what do we do now? Not FOIL, but factor, yeah. So this is going to factor into x plus 6, x plus 1. Numbers that multiply to 6 add to 7, which means that x equals not 6 and 1, negative 6 or negative. Huh? What's there? Is it like blinking?
Like, it might be.
Alright, so x is negative 6 or negative 1. Here's a little twist. That's the answer, but we can't take the log of a negative number. Because here's why. Here's a reminder. What exponent would turn 2 into negative 1? There's none, right? We can't, like, 2 to the 0 is positive 1. 2 to the negative, 5 would be 1 over 32. Like, we can't make this number negative at all. 2 to the 1/2 is square root. So this does not exist. We can't do that. So we can't take the log of a negative number. Which of these numbers, if I plugged it back in, would make us take a log of a negative number? Negative 6. If I plug in negative 6 right here or right here, that's going to be negative 3 or negative 2. So we have to eliminate this solution. But if I try that with negative 1, it's fine. So my answer is just negative 1. So a little extra twist there. All right, so number 6. When we have logs on both sides, we basically want to get them to match or to look similar. That's kind of vague, but you'll see what I mean. Usually these are a lot easier. So what's the big difference between the left side and the right side here? The left has an x and the right doesn't. What's the other difference? The 2. How could I move that 2 so that it looks more like the right side? Yes, we can move this 2 over here and make it x squared. So x is what? Yep, x is 4. So we're saying the inside is equal. X squared is 16, x is 4. Could x be negative 4? No. X cannot be negative 4 because at the very beginning of the problem, we would be taking the log of negative 4. So x cannot be negative 4. Okay. Last one on the notes here. Okay, first of all, this and this are not the same. These things are different. This top one here means like it's natural log of x times natural log of x. Which means we cannot move that 2. We can't do it. Any ideas on how to solve this? No? What if you solve this? What would you do? Factor. Okay. So we'd do x minus 6, a plus 2. And then so a would equal what? 6 or negative 2. Okay, well, what did I do here? What's A? Yeah, A is natural log of x. I substituted. Okay, so A equals 6 or A equals negative 2, which really means that natural log of x equals 6 or natural log of x equals negative 2. So this one actually do the algebra one first, and then we need to recalc. We need to exponentiate both of these. What's the base of this log? E. What's the power? No, not. What's the power in the first one? What's the exponent? 6. 6 is the exponent. That turns E into. That turns E into x. Okay, the other one here. What's the base? E to the negative 2, or we would write that as 1 over E squared equals